Okay, today we're going to be looking at some factoring. I just want to give you a video to help you with some things. So this has been a while since I've done a video, so bear with me if it's a little bit choppy. Okay, the first thing we're going to look at is factoring on largest common factor. So when we look at these, we look at the 5 and the 20. We think to ourselves, what's the largest common factor that goes in the 5 and 20? And that would be 5. So we'd factor out a 5, and then we ask ourselves, what would we have left? And what would we have left? We'd have a y minus a 4, because 5 times a y is 5y, 5 times the 4 is the 20, and the minus just stays between. Okay, on the second one across the top, if you look at a 12 and a 28, the first thing you look at is, okay, what's the largest factor there? And hopefully we can see fairly quickly that the largest common factor is a 4, but then we also have an m to the third and an m squared. So out of those two, we could say we have the largest common factor is an m squared. So the largest common factor of the whole binomial is 4m squared. So if I factor out a 4m squared, what I would be left with from the first term is a 3m, and from the second term, I would be left with just a 7. So if I'm just factoring out the largest common factor, that would be completely factored. On the third one, you first look to see what's common factor of it. A 14, a 7, and a 28. And I would say the largest common factor there is a 7. If you look at an x to the third, or excuse me, an x to the 6, an x to the third, and an x, the largest common factor there would be an x. If you factor out a 7x out of each of these terms, the first term you'd be left with a 2x to the 5th. On the second term, you'd be left with just an x to the 2nd. And on the third term, you'd be left with just a 4. Okay, and again, you can always think about it as redistributing. If you redistributed, you would get the expression that we had started with. Okay, if we look at the next one is just a little bit different, but it will be used when we start factoring by grouping. So if we look at this one, there is a common factor. The common factor happens to be the x minus 3. So if I factor out the x minus a 3, what would I be left with? Well, I'd be left with this x, and I'd still be left with plus a 5. Okay, so when I factor this one out, it'd be an x minus 3 times the quantity x plus a 5. Okay, the next one, we're going to look at factoring trinomials. We're going to look at just the standard method, and then we're also going to look at a box method. Okay, so for this one, when we say the standard method, I'm sure most of us have seen this before, and we actually worked with it last week a little bit, where we're just looking for two numbers that multiply together to give you 8, but add up to a 6. So what we're really thinking is factors of 8. So if you want to look at factor pairs 1 and 8, 2 and 4, and then you just ask yourself, okay, which ones of those add up to a 6? And in this case, it would be the 2 and the 4. So what I have left, I could factor this into h plus 2 and h plus a 4. Okay, if we look at this next one, the first thing you should notice is that there is a negative in the middle. So what I can do, I should be able to think of our patterns, and I should know that I have an x and an x. And then since I have a negative in the middle, I should realize that to add up to get a negative, I'm going to have to get two negatives if they multiply together to give you a positive. So what I'm thinking of now are negative factors of 12. So like a negative 1, a negative 12, a negative 2, a negative 6, a negative 3, a negative 4. So of those pairs, which ones add up to a negative 8? That would be your negative 2 and a negative 6. Okay? I can also think of these two by using a box. Okay? The box will come into play a lot more when we look at the AC method. But if I look here, I'd fill in my box with these things. I'd fill in with an h squared here. I'd fill in with an 8. And then when I ask myself, how did I get an h squared? Well, that would be an h times an h. How did I get the 8? Well, there's a number of ways you can get the 8, but you have to remember that they have to add up to 6h. So, what two things? That would be a 2h and a 4h. So, what would these have been? This would have been a 2. this would have been a 4. Okay, likewise, I could have looked at this second one in a similar way. If I looked at the box for this one, I'd be thinking of an x squared and a 12 here. So I know I've got an x and an x. What two things multiply together to give you 12? But these two boxes have to add up to a negative 8. So in that case, I would be thinking of a negative 2 and a negative 6. If you filled in your boxes, you would get a negative 6x here, a negative 2x here. So these two together give you the negative 8x that we were looking for. So what are your factors? They would be the x minus 2 like we'd had started with, and an x minus a 6. Okay, if I look at this next one, again, if we thought about patterns, the last term is a negative, the first term is a, or the middle term is a negative. If the last term is negative, you should remember that you should have one positive and one negative in the middle. Okay, so we're looking for factors of a negative 15. So those would be a negative 1, a positive 15, a positive 1 and a negative 15, a negative 3 and a positive 5, a positive 3 and a negative 5. So of those sets of factors, which ones add up to a negative 2? That would be the negative 5 and the positive 3. Again, you could have looked at this with a box as well. You'd have a t squared here and a negative 15 here. And if you had to ask yourself what two things again multiply together to give you t squared, that would be a t and a t. How did I get a negative 15? Well, one would have to be a positive, one would have to be a negative. Then you're just trying to figure out what two numbers multiply together to give you 15, but add up to a negative 2. So in my mind, I'm thinking a negative 5 and a positive 3. Therefore, these would be t's along with these. That's a negative 5 here and a 3 here. And again, we get the same factors that we had before. Okay, hopefully I'm not going too fast, but again, you can always stop and rewind and watch and listen again. Okay, next thing is if I have a greatest common factor with trinomials. We start and we put the two things together we had just looked at. So the greatest common factor in this trinomial would be a 3z. So if I factor out a 3z, I'd be left then with a z squared minus 7z plus 6. And then as you work your way down, you're now asking yourself, okay, what two things got multiplied together to give you this trinomial? And again, I'd have a z and I'd have a z. I'm thinking factors of 6. Factors of 6 would be like a 1 and a 6, 2 and a 3. If we look at our patterns, the last number is a positive, but the middle term is a negative. So I would know that I'd need two negatives. So if there are two negatives, then these would all have to be negatives here. Are there any sets that add up to a negative 7? And the answer would be yes, the negative 1 and the negative 6. So this right here would be your factored form. Okay, on this next one, what's common here? Well, I know that there is a 2 common throughout all of these, so I'd factor out a 2. If I factor out that 2, I'd have an a squared minus an ab minus 12b squared. Okay, now this one's a little different because I have two variables, but the process is the same. So the 2 comes down. If I'm thinking about what two things multiply together to give you an a squared, that would be an a and an a. And now how did we get a 12b squared? Well, I know I have to have a b and a b with it. Now I'm thinking of how did I get a negative 12? Those two things have to add up to a negative 1 in the middle. So what two things? Well, a negative 1 and a positive 12. I could have a negative 2 and a positive 6. I could have a negative 3, a positive 4. Now, do any of those add up to a negative 1? No, but I know these two add up to a positive 1. So if I just switch the signs, I know I'd be at that negative 1. So this one you could have a plus 3. This one you could have a minus 4. So it'd be 2 times the quantity a plus 3b times the quantity A minus 4B. Okay, next one. If we factor by grouping or by using a box, okay, I'll show you both methods. The first method I'll show you is by grouping. If I factor by grouping, I'd simply group the first two and the last two terms, and then I'd look in the first two terms and see what is common, and I'd factor that out. So this case, it would be an x. And if I factor out that x, I would be left with an x plus a 3. If I look at the second two terms and ask what's common, I would say a 6. So I would factor out a positive 6, and what I'd be left with is an x plus a 3. And then we ask ourselves, what's the common factor? Well, our common factor now is an x plus a 3. If you pull that x plus a 3 out, what you'd be left with now is the x plus the 6, and you would be done. Now, that's one method. I actually prefer another method, which I just refer to as the box method. Okay, so I use the box method. I fill in each of these boxes with one of the terms from the original expression. And then I simply look across the rows and the columns to see what's common. So if I look across these two right here, I would notice that I have an x squared common. If I look across these two, I would notice that I have a 6 common. Then I look across the columns. If I look these columns, I would have an x common, and these columns, I would have a 3 common. So that is where I get my answer that I'd come up with before, which is x plus 3 times an x squared plus 6. Okay, so if I look at this second one, and I first did it by the grouping method, I grouped the first two, I grouped the last two. The first two, I would say, simply have a y common, so I'd have a y. If I factor out that y, actually I have a y squared, sorry. If I factor out that y squared, I'd be left with a y minus a 1. Okay, what's common out of the second two? Second two, I would say there's a 3 common. So if I factor out that 3, I'd be left with y minus 1. So now, what's common between those two? I would say the y minus a 1 is common. And what I'd be left with is the y squared plus a 3. Okay, if I did it using the box method, which again, I prefer the box method, I'd have a y to the third, I'd have a minus y squared, I'd have a 3y, and I'd have a minus 3. If I look across the rows, I know that there's a y common. Excuse me, y squared. If I look across this row, I know that there's a 3 common. If I look across this row, or this column, excuse me, there's a y common. If I look across this column, I notice there is a minus 1 or a negative 1 that I would say is common. So what am I left with? I'm left with a y squared plus a 3 times a y minus a 1. Okay, that's going to be the end of my first video.